Hello everyone, I'm Professor Junzhou Wu. I come from National Zhongxin University, Department of Bioindustrial Mechatronics Engineering. It's my pleasure to introduce my work awarded by the 2021 the Future Technology Competition. The title of my work is a selectively sensing chip capable of rapidly detecting also phosphate and ions. In this study, we use the PCB fabrication to mass fabrication the PCB chips. And in these chips, it's made by the copper, and we used our patent technology to transfer the copper material to become the copper phosphate, and use a self-designed ion selective layer to coating the surface to form the selectivity of the chip. And we use the homemade potential state for the signal measurement and then translate the signal to the mobile phone. And what is the importance of the also phosphate detection? This slide shows the phosphorus, the circle. The phosphorus in plants, we control the foliage, the growth and the stem and the root. And only soluble also phosphates, such as the dihydrogen phosphate and the monohydrogen phosphate, is suitable for plant uptake. Unfortunately, the amount of phosphates in the environment coming from the animal and the plant residuary is small. The most part coming from the mineral fertilizer. So how to detect the how to detect the phosphate concentration? Appropriate the phosphorus fertilizer dose, we induce the different symptoms. If the plant lacks the phosphate fertilizer, we induce the growth retardation, irrigation in all the leaf and the weaker stem. And if the farmer gives the excessive phosphate fertilization, the plant we induce the death and induce the soil with the acidification. And this situation will lower the alkaline earth cation concentration decrease. And also the excessive phosphate flow into the water, we induce the algae growth. And this situation we induce the eutrophication. So there are some methods by using conventional instrument for the phosphate detection, such as the gas chromatography equipped frame photometric detectors and the ion exchange chromatography equipped as conductive detectors. In contrast, another simple method is the chemical colorimetry. For example, use the ammonium molybdate with the reaction with the phosphate to produce the ammonium phosphate molybdate. But this reaction will be affected by the nitrite and the sulfide and the silicate ions. And finally, we use the vitamin C to reduce the ammonium phosphate molybdate to produce the meridian blue and use the UV visible reader to detect the phosphate concentration. But in this situation, we can find an unmet niche, is to develop a miniature phosphate sensing chip and a portable reader for on-site detection. So in our work, we use the PCB fabrication for the massive production of the copper-based chip and use our Taiwan pattern to transfer the copper material to become the copper phosphate. And these copper phosphates have the good specificity for the phosphate ions. And we design this chip like this. We have the working container and the reference container, and use the source bridge to connect the two containers. And then we use the external silver chloride to demonstrate the copper phosphate the pseudo reference electrode stability. Like this, you can see the open circuit potential measure the two electrodes with the small potential drift, indicating the reference electrodes stability is quite excellent. And then we can directly drip the phosphate solution in the working container for the on-chip measurement. You can see the current, the peak current have the good reaction with the phosphate concentration. And you can get the calibration curve from the peak current with the phosphate concentration. And then we can get the amperometry for the detection at a fixed potential at about 0.1 volt versus the chip type copper phosphate reference electrodes. In this case, we also can get the relationship from the current and the phosphate concentration. And this the linear range will reach the plateau as the concentration excessive than 1 millimolar. Here you can see the slope about -2 microampere per millimolar. And this the result indicates this the copper phosphate chip have a good relation with the or sensitivity with the phosphate concentration. And then we cover a self-designed phosphate selected layer on the working electrode surface. And we still use the amperometry for the phosphate detection. Here you can see the slope can increase to the 10 microampere per millimolar. It means this the phosphate selective layer can increase the selectivity for the phosphate detection. And then the right-hand side picture shows the interference of the other anion effect on the measurement. So when you compare the response with the phosphate solution, the deviation is quite small, only have the 5%. And finally, we prepare the solution extractants from the soil, and we directly drip the extractant solution on the working container and then use the safe-made potential state to measure the current relation with the phosphate concentration, and finally send this the data to the mobile phone. And the right-hand side picture, you can see if we drop the phosphate solution into the chip, the current will decrease with the phosphate concentration increase. In the red brackets show if we drop the mixture of the interference, like the sulfate, nitride, and chloride ion in the solution, there is no significant increase or decrease in the signal. So indicate this the chip have the good selectivity for the phosphate detection. So we use the titration method to detect the phosphate solution in the soil extracted solution, like the sample 1 and the sample 2. We use the Meridian blue method as the standard method to get the sample concentration. And then we can compare our method. This device can detect the concentration in the 0.2 to the 0.3 millimolar. And the sample 2 also can use this method to detect the range of the phosphate concentration. And finally, we integrate this chip with the wireless and the portable potential state and show this the data in the notebook and simultaneously at the mobile phone. So in the future, we can perform the easy, rapid, and sensitive and on-site detection for the phosphate detection. And we think the technique have a wider application in soil, like to determine the soil fertilized degrees, and for the environmental water for a determination of purification degrees. Also can use this microchip for the agriculture product and blood sample detection. And I also want to thank our co-worker, Professor Shen Yong and Professor Lai Hongyu, to give me many suggestions in this work. And thanks for your attention.